Next, for sequences and series. Find the third element of a geometric sequence whose fifth element is 81 and whose ninth element is 16. We can solve the third element or the third term of this geometric sequence when we have the first term and the common ratio, because this formula here, this formula describes all terms of a geometric sequence. You have a sub n is equal to a sub 1 and then r to the power of n minus 1. If you're going to solve for a sub 3, that would be our n. But we don't know what a sub 1 is. We don't also know what is the common ratio. What we are only given with is the fifth element or the fifth term and the ninth term or element. We can use the relationships of these two different elements or terms in order for us to structure a formula that will allow us to solve for either a sub 1 or the common ratio. Because if again, when we are going to solve for the third element or the third term, we need both of them. Now, if it's a sub 5 or the fifth term, it is actually similar to this notation, a sub 1 r 5 minus 1. So that would mean 81 is the result when we multiply our first term, to which we don't know yet, and our common ratio to the power of 4. We also don't know the value of the common ratio. Next is, for our ninth element, we also know that it's a result of multiplying our first element or term, r to the power of 9 minus 1, which gives us this second equation. 16 is equal to a sub 1 r to the power of 8. So we have two equations now. This is for our fifth element and this is for our ninth element. What is the purpose of this? Notice here that in both equations we have a sub 1 or a first term and r. We can just simply pair them because when we talk about common ratio, we will start with solving for the common ratio. Common ratio can be solved by taking the quotient of two successive terms of a geometric sequence. Now, even if the fifth and ninth are not successive, if we are going to divide both of them, let's say 16 over 81, this is our ninth element versus our fifth element. This is actually equal to a notation where we're just also dividing the right hand side of the equations. A sub 1 r to the power of 8 over a sub 1 r to the power of 4. Okay? Now take a look at this relationship alone. If we are going to do this, again, we are dividing equalities, just like 2 is equal to 2, 4 is equal to 4. So when we divide 4 divided by 2 is equal to 4 divided by 2. We are dividing equalities. This would mean the result or the resulting quotients should also be equal. If we are going to continue that, we could cancel this, leaving an equation which is 16 over 81. This will be the version of these equations is equal to, and we apply here the laws of exponents, specifically the division law of exponent or the quotient rule, r 8 minus 4, which is 4. If we have this expression now, we can now solve for r. Okay, r, let me write it here, r, we will take the fourth root, okay, fourth root of this side. Let's also take the fourth root of the left hand side, and by symmetric property, r is equal to the fourth root of 16 over 81. 16 and 81 are both perfect fourth numbers, so that is actually 2 over the fourth root of 81, 3. This is our common ratio. This common ratio now will be used to solve for the first term, because we need the first term as well in solving for the third term of the mentioned geometric sequence. We could apply it here, we could apply it here as well. Let me just choose this here because the exponent is just 4 and it would not be too large for me to take the common ratio 2/3 raised to the power of 4. This is actually equal to this one here. 81 is equal to a sub 1 times r, which is our 2/3 as solved earlier, raised to the power of 4. This means this 81 is equal to a sub 1. The 2/3 to the power of 4 is times 16 over 81. To cancel this, we will be multiplying both sides by 81 over 16. So that this will be cancelled, that will be cancelled. We are left here with a. But do the same thing on the other side. 81 over 16. Take note that 81 here is all over 1. So we can now solve. Let me place separator here. Our a sub 1 now is equal to 81 times 81 is 6,561 all over 16 times 1, 16. This is now our first term, or the first element of the geometric sequence together with the common ratio. We are not actually asked to solve for this, but we need these two to solve now for our intended value. A sub 3, or the third element. This is a result of a sub 1 times r to the power of 3 minus 1. This is equal to, you have 6, 5, 6, 1 over 16 for our a sub 1 times, you have 2/3 as our ratio. Just going to automatically replace here 2 because 3 minus 1 is 2. This will now be equal to 6, 5, 6, 1 all over 16 times the square of 2 is 4, the square of 3 is 9. If we are going to simplify this, we can actually come up with this result because 6,561 can be divided by 9. That's 729. And 4 over 16 is just 1/4 or over 4. By the way, I made an error here. This is not a sub 1. This is actually what we are asking for, a sub 3. So the third term of a geometric sequence whose fifth and ninth terms are 81 and 16 respectively, with their common ratio in the first term we have solved in this process is equal to 729 over 4. Next, for sequences and series. Subscribe now!